Then you have seventh problem. A man of mass 30 kg uses a rope to climb which bears only 450 Newton. What is the maximum acceleration with which he can climb safely? So this problem is similar to a lift problem. If you take a lift, when the lift is moving upwards with an acceleration A, then a net force of mg plus ma acts on the body by this floor. Similarly, if you take a rope, this is a rope, and here the man is climbing along the rope like this. This is man climbing the rope with an acceleration A. Then a force of mg plus ma acts on the man. In turn, the man applies the same force on the rope. The man applies a net force of mg plus ma on the rope. Then, because of this force, tension is produced here. This is tension. So, if the maximum tension above which the rope can break is mg plus ma. So, if this mg plus ma, that means the force exerted by the man on the rope is more than the maximum tension that the rope can bear, then the rope can break. So, without breaking the rope, the acceleration, maximum acceleration with which he can climb safely, if you take, then in this case T is equal to mg plus ma. This is a maximum. So, G plus a maximum is equal to T by m. Here T is the maximum tension that the rope can bear. So, here the rope bears 450 Newton. That means the tension, maximum tension produced in the rope without breaking is 450 Newton. This is the maximum force or maximum tension produced in the rope without break is 450 Newton. And here mass of the man is given as 30 kg. And acceleration due to gravity, you can take this as g is equal to 10 meter per second square. So, g plus or g means 10 plus a maximum is equal to, so T is 450 by mass of the man is 30. So, 300 cancel, this is 15. So, a maximum is equal to maximum acceleration with which the man can climb the rope without any problem or safely. A maximum is equal to 15 minus 10. This is 5 meter per second square. If the man climbs with more than this acceleration, then force exerted by the man on the rope is more than 450 Newton. So, when the force exerted by the man on the rope is more than 450 Newton, then the rope simply breaks, because the rope can bear only this much of a force, 450 Newton. That is the maximum tension produced in the rope without any break. If the tension produced in the rope is more than 450 Newton, then rope simply breaks. So tension is produced when there is frictional force. So here frictional force is created by the man. So force created by the man is force produced by the man on the rope is mg plus ma when the man climbs with an acceleration a. So similar to lift problem. When the lift is moving upwards, then force exerted by the body on the floor or floor on the body, both are same. Force exerted by the lift, floor of the lift on the body is mg plus ma. Similarly here, when the man climbs the rope, that means like this, moving like this, with an acceleration a, then the man applies a force of mg plus ma on the rope. Maximum for maximum acceleration. So this is the formula, T equal mg plus ma maximum. If the tension is more than 50 Newton, so this rope simply breaks. So we use this formula, T equal mg plus ma maximum. Using this, a maximum equal to 5 meter per second square. So that is the answer. Next, eighth problem. A force of 5 Newton produces an acceleration of 8 meter per second square on a mass m1 and acceleration of 24 meter per second square on a mass m2. What acceleration would the same force provide if both the masses are joined together? So here this is one body of mass m1 and this is another body of mass m2. Same force is applied, say 5 Newton. So 5 Newton force is applied on this mass m1, produces an acceleration of 8 meter per second square. So for this, if you take acceleration a1 is equal to 8 meter per second square, mass m1 equal to f by a1, because f is equal to ma. So m1 is equal to mass of the first body m1 equal to force acting on the first body by acceleration produced in the first body. So here force is 5 Newton. So 5 by acceleration produced here is 8. So m1 is equal to 5 by 8 kg. Similarly, for the second body, the same force is applied, 5 Newton force is applied, 5 Newton force is applied, produce acceleration of 24 meter per second square. So using that data, you can calculate m2. m2 as m2 is equal to force by acceleration in the second body, a2. So here force is same as 5 by acceleration is 24. So 5 by 24 kg, this is the mass of the second body. Now these two bodies are joined together like this. Then total mass becomes m1 plus m2. When these two are joined together, these two act as a single body of mass m1 plus m2. Now the same force is applied like this, 5 Newton. We have to calculate the acceleration here. So for this, acceleration A is equal to force by total mass m1 plus m2. Same force is applied, 5 by m1 plus m2. m1 is 5 by 8 plus m2 is 5 by 24. So this is equal to 5 by, here 5 is common in the denominator. This is 1 by 8 plus 1 by 24. 5 cancel. Then this is equal to 1 by, here in the denominator the LCM is 24. So this is 8, 3 times, so 3 plus 1 time. So this is 24 by 3 plus 1, 4. This is 6. So 6 meter per second square. This is acceleration produced in the combined mass. So to find the force here, force of the nail on the hammer, force of the nail on the hammer, F is equal to MA, M is equal to V minus U by T, V minus U by T. So force on the hammer by the nail is equal to mass of the hammer into acceleration produced in the hammer, V minus U by T. So F is equal to force acting on the hammer by the nail. Mass of the hammer is given as 400 gram. 400 gram means 0.4 kg. 400 gram means 0.4 kg. And here time of contact is 0.01 second. So during this time the hammer is going to be stopped by the nail. So 0.01 second. So during that time interval the velocity change takes place. So F is equal to mass of the hammer is 0.4 into V minus U. This is minus 30 by time is 0.01. So this is equal to minus 4 into 3 by 0.01. So F is equal to minus 12 by 10 power minus 2, which is 1200. So F is equal to numerical value if you take 1200 Newton. This is the force exerted by the nail on the hammer. Force exerted by the nail on the hammer, 1200 Newton. Next time, find the acceleration of the blocks under tension in the string. G is given as 10 meter per second square. So here this is a table. On the table there is a mass 3 kg connected by a string which passes over a pulley like this, and at the free end of the string another 3 kg mass is attached. So this is the system of two bodies, and we have to find the acceleration of this system. For this you take free body diagram on the two masses. If you take this mass, what are the forces acting on this body? So here mg, this is one force acting on this body. Weight of the body acts vertically downwards. So mg is the force acting on the body vertically downwards. Then because of this, tension is created in the string T. Tension is created in the string T. So if you take this free body diagram representing the various forces acting on the body when the body is taken alone. So this is the 3 kg mass, and this is one force acting downwards, another force is T acting upwards like this. And because of this, if the mass comes downwards with an acceleration A like this, if it is moving like this, two bodies moving like this, so this body comes downwards with an acceleration A. So this is A. So this is the free body diagram. Free body diagram means representing various forces acting on the body when the body is taken alone. So here this is 3 kg body, and weight mg acts vertically downwards, tension acts upwards like this. Because of this, the body moves downwards with an acceleration A, say. Then what is the net force on this body? Because the body is moving downwards, then mg is more than T. Hence net force is mg minus T. mg is acting downwards, so tension is acting upwards, then net downward force is mg minus T. Because of this force, net downward force, acceleration is produced. Hence according to Newton's second law, F is equal to ma, net force is equal to mass of the body into acceleration produced in that body. So this is the net force acting on this body, 3 kg mass. So ma. So this is equation 1. And you take the second body. This is the second body. Again you can write the various forces acting on that one. So here, because this is in contact with the table, say if this is some table, then mg acts vertically downwards like this, and a normal reaction is the force acting on the body by the force normal to the surface. So this is mg, which acts vertically downwards, weight of the body. The normal reaction, that is the force exerted by the surface on the body in the upward direction normal to the surface. Then third one is tension, because here tension is produced in the string. Because of this, tension is produced here. Because of this force, tension is produced in the string like this. So on the second body, tension is acting like this, and since the body is moving on the surface only like this in the horizontal direction, this n and mg cancels out, both are equal. Then net force is simply tension. So for this you write the Newton's second law as T is equal to ma, where a is acceleration of the block like this. So here the block also moves like this, because this is a string which is inextensible. Then when this body moves like this body also moves like this. If a is the acceleration of this body, this is also moves with the same acceleration a. So you can write T is equal to ma. So from this equation 1 and 2, you can write mg minus ma is equal to ma. By so you can write 2 ma is equal to mg, because here both the masses are same. Here 3 kg, 3 kg. That's why we written like this. Cancel. Then A is equal to G by 2. So A is equal to G by 2. G is 10, 10 by 2. So this is 5 meter per second square. So this is the acceleration of the system. The acceleration of the system. That is acceleration of the blocks. Next, 11th problem. 3 identical blocks, each of mass 10 kg, are pulled as shown on the horizontal frictionless surface. If the tension in the rope is 30 Newton, what is the acceleration of each block, and what are the tensions in the other ropes? So here 3 blocks, identical blocks of same mass 10 kg, connected by strings like this. Ten kg. This is also 10 kg, connected by different strings like this. So they are on the horizontal frictionless surface. There is no friction. And this last one is pulled by a force of 30 Newton. This is 30 Newton force. So it is pulled by a force of 30 Newton. So here this is tension T1 or this is T2. T1, T2. So we have to calculate T1, T2 and acceleration of the system. When the 3 blocks are pulled by a force of 30 Newton, the 3 blocks move together with the same acceleration, and we have to find the acceleration of the system. So acceleration and T1 and T2 we have to calculate. So for this you take free body diagram. So for this if you take, this is force which acts in the forward direction, then tension is produced in the string in the opposite direction, because tension is always acts or produced in the string which is opposite to the external force, other force. So here this body is pulled by a force of 30 Newton. So when the body is pulled like this, so tension T2 will be acting like this. Tension T2 in the string will act like this. So this is the free body diagram. Of course there are other forces mg and normal reaction, because this is horizontal, the block is kept on the horizontal surface and moving on the along the surface, moving along the surface like this. Then these two cancels out. Both are equal, upward force and downward force. Both are equal because the body moves along the surface only. So here the body, this block moves because of the net force. So since it is moving like this, F is more than T2. So F minus T2, this is equal to, this is the net force acting on the third block. F minus T2 is the net force acting on the block. Because of this net force, acceleration is produced in this block. So if A is the acceleration produced here, if A is the acceleration of 3 blocks system, then this moves with an acceleration A, this moves with an acceleration A, this also moves with the same acceleration A. So if you take for this block free body diagram, writing the various forces on the, or representing various forces acting on the block. So 4 forces are acting on the block. One is pulling force, normal reaction exerted by the surface on the block in the upward direction, weight of the body, that is gravitation, gravitational force, which is weight, acts downwards, and because of this string, because it is connected by the string, tension is produced in the string, and this tension is opposite to the other force, pulling force, like this. So it will be like this, tension is like this for this block. So net force is F minus T2. Because of this net force, A is the acceleration produced in this block. From Newton's second law, you can write net force is equal to mass of the block into E. So F minus T2 is equal to ma. This is one equation. Then for the second block, if you write, for the second block, this is T2. For the second block, T2 is the force acting on the block in the forward direction, and for this T1 will be like this. So these are the two forces which causes the motion along the surface. Of course, there is N and mg cancels out. So again you can write T2 minus T1, this is equal to ma. T2 minus T1. T2 is more than T1 because system is moving like this. So T2 minus T1 is the net force acting on the second block, which causes acceleration A in the second block. Then according to Newton's second law, net force is equal to mass into acceleration. So T2 minus T1 equal to ma. This is equation 2. Then you have this third block. For this, the only force acting on is T1. And of course, normal reaction mg cancels out. So T1 is the only force acting on this block which causes acceleration. This is the free body diagram for the third block. So writing the second law, T1 is equal to ma. T1 is equal to ma. This is equation 3. In this way, when the blocks are connected by strings, we have to write the free body diagram for each block. That means we have to represent the various forces acting on the block. Then you find the net force acting on the block and then apply second law. Then combining these three equations, when these three are added, this is minus T1 plus T1, these two are cancelled. Then this is minus T2 plus T2, cancelled. Then on the left hand side, the only force is F. So F is equal to, these three are combined, added, ma plus ma plus ma, 3 ma. So this is 3 ma. So F is equal to 3 ma, and here pulling force is 30 Newton. So you can write 3 ma. So 3 ma. 3 ma is equal to F. That is 3 into mass is 10 into A is equal to 30. Then A is equal to 1. So 1 meter per second square. This is the acceleration produced in the system. A is equal to 1 meter per second square. So each block is accelerated by 1 meter per second square. Then T1. T1 is equal to, you have T1 equal to ma. M is 10, A is 1. So T1 is equal to 10 Newton. So tension produced in the string between first two blocks is 10 Newton. Similarly, if you take this T2 minus T1 is 10. This is equal to mass into acceleration, 10 into 1. So T2 is equal to 10 minus 10 becomes plus 10. So this is 20 Newton. Upon resubstitution in the second equation, T1 is already we calculated as 10. When this is substituted in this equation, then you get T2 as 20 Newton. So tension produced in the string between the first two blocks is 10 Newton, and tension produced in the string between the other two blocks is 20 Newton. So this is answer, tensions and acceleration of the system. A motor cycle of mass 100 kg is running at 10 meter per second. If its engine develops an extra linear momentum of 2000 Newton second, calculate the new velocity of motor cycle. So motor cycle of mass 100 kg is running at 10 meter per second. So this is a motor cycle. It is running with a velocity of 10 meter per second, and its mass is 100 kg. Then its momentum is P1 equal to mu, mass into velocity. This is 100 into 10. So initial momentum of the motor cycle is 1000 Newton second. Extra linear momentum, additional momentum. So final momentum, if P2 is the final momentum is equal to initial momentum plus extra momentum, P extra. Final momentum is equal to initial momentum P1 plus extra momentum. So this is initial momentum is 1000 plus extra momentum is 2000 Newton second. Then final momentum becomes 3000 Newton second. Final momentum is 3000 Newton second. So we have to calculate the new velocity of the motor cycle. So P2, this is the final momentum, this is 3000 Newton second, but P2 equal to mass into final velocity, mv, this is equal to 3000. So V is equal to 3000 by mass, which is mass is 100. Then final velocity or new velocity is 30 meter per second. So here it is given that the engine develops an extra linear momentum of 2000. That is not the final momentum, that is the extra linear momentum. Already it has certain momentum, linear momentum of 1000 Newton second. Initially it has this much of linear momentum. Engine develops an extra linear momentum of 2000. Then final momentum becomes initial momentum plus extra momentum, that is 3000. So this is the final momentum. Then final velocity. So mass into final velocity is final momentum. So V is equal to final velocity equal to 30 meter per second. That is the new velocity. Final velocity is the new velocity.